we wanted to find out what is the, so we wanted to find out what is this point. What is the x where electric field is maximum or minimum, right? So this is the point that we want to find. And we can also find out the maximum electric field and the minimum electric field, right? So what is the goal in here? Goal is to find out the point at which E is maximum or minimum. Right. Right. And then the second goal is to find out what is the maximum value or minimum value. So these are the two goals, right? And if you remember your 11th standard class, so do you remember how can we maximize any function? How did we maximize the function? Do you remember? Yes. Do you remember how did we maximize this function?
No, sir.
Okay, so to maximize or minimize any function, this question we have done, right? This question we have done in electric charge and force in the Coulomb's law topic. In the Coulomb's law topic or in equilibrium, we have done this part, right? So, okay, if you don't remember, then I will talk about that thing that where we have not that thing. So I will talk about that. But yeah, so to maximize or minimize, what are the steps? First step is to take the first order differentiation. Right. Which is what? Which is just find out what is dy by dx. This is the first order differentiation. Second step, put dy by dx equals to 0, right? And solve for x. This is what we call, this will give the critical points. What is the critical points? Where the maxima or minima occurs. Right. The third step is to check if we have minima or if we have maxima. So for maxima, we have to find out, or minima, we have to, okay, so I will do this. Maxima or minima, we have to again take another differentiation. Which will give the maximum. Right. And to check whether we get maxima or minima, if we have d square y by dx square, this is the another differentiation greater than 0, then we have minima. And if we have d square y by dx square less than 0, then this is maximum. So we have to follow all these steps. Is this one clear to you? Is this one clear?
Yes, yes, sir.
Yeah. So what is the function that we have? We have a function which is this one, and we have two maximums. So the question is to maximize or minimize E, which is what? Which is function of x, which is kqx divided by x square plus a square power 3 by 2. This is the function, right? Clear?
Yes, sir.
So we have to take the first step is to take dy by dx, right? So let us follow the first step one. dE by dx. What would be that? So what kind of function is this one? What kind of function is this one? D by dx of kqx divided by x square plus a square power 3 by 2. What kind of function is this one? This is something like u by v. So if you take the differentiation of this thing, so y dash would be u dash v minus u dash divided by v square, right? Clear?
Yes, sir.
So what is u? U is kqx, right? Or we can take this kq outside because this is a constant, so we can take this one outside, right? Kq is outside, and we have x by this thing. So let us write u as x and v as this whole. Please stop me and ask if you have any doubt, right? So u dash is simply dx by dx, which is what? V dash would be how much? What would be V dash? Can you tell?
V dash would be x 3 by 2 x 2x.
No. First, the algebraic one.
Okay.
First, we have done this one, and then we do the differentiation of the inside function, right? The chain rule. So d by dx of x square plus x. Right? This is the rule, right?
Yes,
Right?
sir.
So this would be 2 by 2 and x square, a square. 3 by 2 minus 1 is 1 by 2. And then this is simply 2x. Because differentiation of a square is a constant quantity, that will be 0. So this is 2 and 2 cancels. This is 3x, x square plus a square power 5. This is b. Am I correct or wrong? Is this one correct?
Yes, sir.
Okay, now we have to put this one in here. So dE by dx. This is kq. And we have u dash, which is 1 into v, which is x square plus a square 3 by 2, minus u, which is x, v dash, which is 3x and x square plus a square 1 by 2, and divided by v square, which is x square plus a square and 3 by 2, and then whole square. So this one and this one will cancel. Right, is this one clear? Is this thing clear?
Yes, sir.
So now let us simplify this thing further. So this is KQ and x square plus a square by 2 and minus q, right? Minus 3, right? Because we are writing it separately. So this one separately, this one separately. And this is 3x square and x square plus a square half minus 3. Is this thing clear to you?
Yes, sir.
So what we can, what would be this thing? So this is KQ and x square plus a square. This is 6, 3 minus 6 by 2, right? And then this is minus 3x square and then x square plus a square. And this is 1 minus 6 by 2. And this is, so this is how much? This is KQ and x square plus a square, and this is minus 3 by 2 and minus 3x square, and this is x square plus a square, and this is minus 5 by 2. So this is dE by dx. Right, is this one clear?
Yes, sir.
Okay, so now the second step, right? Second step is we have to put it equal to 0, right? That is the second step. So we have to put dy by dx equals to 0. So follow the second step. dE by dx equals to 0. This will give us the critical point, right? So if we put it dE by dx equals to 0, so this kq and x square plus a square minus 3 by 2 and minus 3x square, x square plus a square, and that is minus 5 by 2, right? So this is there and this is equal to 0. We can take x square and a square minus 3 by 2 outside, and this will become how much? This is 1 minus 3x square, and this is how much? If I take 3 by 2 from here, so this is minus 2 by 2, right? Clear?
Yes, sir.
So this is minus 1 and this is equal to 0. So this part is 0, this part is 0, and all of these parts are 0, right? So let's take this part equals to 0. So we have 1 minus 3x square divided by x square plus a square, right? Because this is minus 1. Let me write this one here. So this is x square plus a square minus 1, and this is equal to 0 because this is 0, this is 0, and this one is 0. Whole thing are 0, right? So I can take this one equals to 0 or this one equal to 0, or I can take because k and q cannot be 0, right? So only this one and this one is 0, right? Okay, so we will not solve this one, but will not solve this one. Let us solve only this one. So this is 1 minus 3x square divided by x square plus a square equals to 0. So we take this thing the other side, right? 1 equals to 3x square and x square plus a square. We take cross multiplication. So x square plus a square is 3x square. And then a square is 2x square. So 2x square or x square is a square by 2. So x is right. X is root of a square by 2. So this would be plus minus a by root. Right, so we have two values. X is plus root 2 plus a by root 2. And x is this part clear to you? Is this thing clear? Yeah, you are muted or
Yeah, yes, sir.
yeah, so you see that we have two values. So on each of these values, we can have either maxima or minimum. I will not go into detail, right? You can check that. But from the graph, we have already drawn the graph. So can you tell me that which one would be plus root a by 2 and which one would be minus root a by 2? Which one would be that? Which one would be maxima? Which one would be minimum? So you have two values. X is a by root 2 and a minus a by root. So which would be maxima and which would be minima from the graph itself? What can you tell me? Yeah. At which point you see that the graph is going the maximum value? Yes, this is the origin, right? This is the origin. So this point would surely be a by root. Clear? Because this is positive. And this point will surely be minus a by root. Is it clear?
Yes, sir.
So this would be maxima and this is I have told it by using the graph, right? But if we follow these two and third and fourth step, then we can determine whether it is maximum from the calculations. But from the graph, we can already see that this point is maxima. This is positive. So this is maxima. So a by root 2 would be maxima and minus a by root 2 will be minimum. Is it clear?
Yes, sir.
So please note down this portion and then we will talk about the maximum value, maximum or minimum value. Please note down this. So whenever you need me to scroll down this thing, please do. This part, I guess we have already noted. So just write from the group, right?
Yes, sir.
Yeah, whenever you want me to scroll down on the screen, please.
So can you scroll down?
Is it okay?
Yes.
Yes.
So can you scroll down?
Yeah, whenever you have noted, Mr. Yeah, whenever you want me to scroll down the screen, please do.
Yes, again you scroll down.
Yeah, quickly note this one down and if you have other questions. Yeah, noted.
Almost once. Yes, sir.
Okay, so now let us summarize what did we do, right? What did we do? And this way. So we have a ring charge, right? We have a ring charge. Okay. Right, this one is a ring charge. And then this has a radius A. And at this axis, we have some point and we are, let's say that this distance is X. And we are calculating the electric field at this point. So let's say P. So electric field at this point is simply KQX. And this is X square plus A square. And 3 pi. Which means that this point can be here, this point can be here, this point can be here, this point can be here. Everywhere this point can be. So this point is a variable. We can put this point in here. Right. So from the graph, we see that this will increase. It will go to some maximum value and then it will start decreasing. So this is the graph. Right. So this is the graph that we have obtained. This is how the electric field will vary. It will go maximum and then it will decrease. Similarly, in this side, it will go maximum and this will then decrease. So, right. So this point that we have found out, this is the point at x equals to a by root 2 distance. This electric field would be maximum if you place your point, if you calculate the electric field at this point. So at this point, the electric field would be maximum, and at this point, the electric field would be minimum, right? This is minus a by root. Is it clear?
Yes, sir.
Yes. Yeah, so this was about the electric field due to a ring charge, right? And yeah, we'll talk about the electric field due to the spherical distribution and the hollow sphere and the conducting sphere, all those things. But those uses the idea of Gauss. So we'll do that in electric flux in Gauss law chapter, right? And Gauss law topic. But the next topic that we have, I will give this as your homework. So your homework would be find the maximum value, right? Why this is so the homework is find the maximum value of electric field for a ring charge distribution. Right. This is very simple, right? And what do you already know? That electric field is varying like KQX divided by x square plus a square 3 by 2. You know that at x equals to a by root 2, P is max. So you have to just do what? You have to put x equals to a by root 2 in this equation and you will get the maximum value. This is the question. Right. Please note down this question. Try this at your home, and in the next class, I will ask about this. And yeah, I will then talk about the force on a charged particle in the presence of the electron. Please note down this question. Right. Quickly note down this question and then we'll talk about the next topic.
Done, sir.
Done. Okay, so the next topic is force on charged particle. We have done all the questions, right? So we have done this question. This is related with the force on charged particles, and this is related with the torques. So we have done all this question. Now, yeah, let us talk about force on charged particle in the presence of the electron. So we have a uniform, right? This is clean. So we have some uniform electric field. This thing we have already done. So I will just recap in. This is the electric field. And let's say you put some charge particle in it. So you have this charge particle. This is plus. So this will experience some force, right? And the force would be in the direction of the electric field, and that would be in this direction. This force would be equal to Q. So it will experience the force in the right hand side, right? If I have a negative charge, then what would be the force? Force would be in the direction or against the direction. What would be the force?
In the direction.
So force would be opposite direction, right? That would be minus Q. So for positive charge, force is same direction as electric field. So F is Q, right? And second point is for negative charge, F is against the direction of this you have already got, right? So F is minus Q, right? So is this thing clear?
Yes, sir.
You have done one question using this thing. So I will, yeah, I will just recap two questions that you have done already. One question there was that, let's say if you have a charge in the air, this is ground, right? This is ground. And you have charge in the air, right? And you want to put this charge, let's say this is electron. Let's say this is electron, right? This is electron, which is minus E. And you want to put this in the air. So where should, what would be the electric field, or what would be the direction of the electric field that you provide externally so that this doesn't fall, right? Because if there is no electric field, then this will fall due to gravity, right? So we require a force in this direction that will balance. F external will balance mg so that it doesn't fall. Right, if I want to put this electron in the air, so then I have to provide some external force so that it doesn't fall in this on the ground, right? Because if you have something, let's say some box, some anything, and you put it in the air, it will always drop down, right? But if we have this charge electron and this is not dropping down, which means that we are providing some electric field whether in this direction or in this direction. That depends upon the charge. Right. So now you tell me that what should be the direction of the electric field? What should be the direction of the electric field? We already know that the force that we require is upward. So what should be the direction of the electric field that we have? Did you understand the question?
The direction of the electric field should be
What kind of yeah, towards
towards
upward
the,
or towards M?
the ground.
Towards the ground, downward, right? Because F external is upwards, force is upwards. And we have a negative charge, which means that the electric field should be opposite. So this should be the direction of the electric, right? So we are providing some uniform electric field in this direction. And this electric field will create a force on this charge. So force on this charge would be in this direction, right?
Yes,
Right?
sir.
And this force will balance this mg. So we have F, this is mg, and the magnitude of this electric field would be, so E will be downwards. Right, this is the first point. Magnitude would be what? So F is mg, and this is QE, which is mg. This question you have done in your class already. So electric field would be mg by Q, which is E. So this is the magnitude of the electric field that you have to provide to make this electron in the air, right? This will not drop down. This electron will not drop down if you provide some external field in the downward direction, and that has the magnitude this. So this question you have done, right? Right?
Yes, sir.
Okay, and yeah, there is one more question that you have done already. So, and what was that? So I will do a different question, which you have not done. Right. So the other type of question that you get is tunnel question. Tunnel question. And what is that? Oh, you got disconnected. Yeah, the tunnel question is what? So you will have this kind of tunnel. And let's say this is a positive charge. This is negative charge. So the electric field is in this direction. Right, this is the direction of the electric. This is the direction of the electric field. So let's say that if I put some electron, or let's say some proton in this place. So I have this proton, right? And I project this proton with some u velocity. Right, I project this proton with u velocity. So the trajectory that it will follow would be like this. So the trajectory of this proton would be something like this one, right? Because it is experiencing, the trajectory would be something like this. And why? Because this is experiencing, this is the electric field, right? This is the electric field that is there. So due to this electric field, this proton will experience a force in this direction. Right? And what is the amount of this force? This force is QE. So due to this force, there would be acceleration. And what would be that acceleration? So acceleration would be QE by M. due to this acceleration, downward acceleration, it will follow this path, right? Because this is the example of the projectile motion. So you have a projectile, and if I don't have an angular projection, let's say I have this horizontal, this thing. So then for this case, I have this path, right? This is the initial velocity that I provide, and the acceleration that I have is downward, which is g. So same like the projectile. This will also follow this path. So this question you have done right. And if you have an electron, so electron will follow this path. Let's say this is the electron. So electron will go from here to here because electron will feel the force in this direction. So because this is electron, so the force on this electron would be in this direction, opposite direction of the electron. So electron will follow this path, proton will follow this path. This question we have done already, so I will do a different question on what is the question. So this you have done right. Yes, do you remember this question in your class?
Yes, sir.
Yeah, so I will not talk about this question, right? You have to just remember the projectile motion. So the idea that we have to use in this question is the projectile motion. And then you have acceleration, which is downwards. Which is downwards or upwards depending upon the charge. So this is a constant acceleration. Right. So this is the thing that you have to figure out in this question. Okay, so now the question that I'm talking about is this. So what is the question that you have? This one and this. Right, so let us do this. Now you see that in this question, right, in this question, what do we have? We have this uniform charge density, right? This is the thing that we have. Right, and then this is the point that we have, initial point. This is R naught. And this is some charge. You have some point charge, let's say Q. Right, it's released from rest at a distance r naught from positive line charge with uniform density. The speed v of the point charge as function of instantaneous distance r from line charge is proportional to. Right. So due to this thing, this will experience some electric field at this point. Right. And due to line charge distribution, what do we have? Due to line charge, we have the electric field, which is lambda by 2 pi epsilon naught r. This is let's say at this point or at this point, at this point. So this is the electric field due to line charge distribution. Right? Clear?
Yes, sir.
So we have a charge which is experiencing an electric field. So this charge is in the presence of the electric field. So this is a positive charge. So it will experience some electric field in this direction. So it will experience some force. Right? And that force would be Q. So due to this force, this charge will move in this side. Is it clear? Is it clear?
Yes.
So due to this force, this charge will move in this side and it will have some velocity. So we have to find the velocity with which this charge will move. So we know that what is the force? Force is QE, and we know that this is MA, right? So this is QE, and yeah, so then what do we have? So acceleration is QE by, this is the acceleration that we have, right? What is this electric field? The electric field value we already know. So electric field is lambda by 2 pi, and let's say that r naught and r, so we just name it as x. Let's say that this distance is x. So this is variable 2 pi epsilon naught and x. So this is lambda m, and then this is 2 pi epsilon naught and x. Lambda is how much? Yeah, let's keep this lambda as it is. So this is q lambda by 2 pi epsilon naught m and x. This is the acceleration that we have. Is it clear?
Yes, sir.
So what kind of acceleration is this one? This is uniform acceleration or this is variable acceleration? Can you tell me about that? What kind of acceleration is that?
Variable acceleration.
Variable acceleration, good. And the goal is to find out velocity. Final velocity we have to find out. Yes?
I have another class now, sir.
Okay, yeah. So we'll talk about this question in the next class. Okay, we'll stop here. So bye bye, Rishida. Bye. See you
Bye,
soon.
bye.
Bye bye.